Welcome to Study Loop.
This is the answer to Chapter 13, problem number 31 from the Smith Organic Chemistry textbook. And in this problem, we're asked for each compound, assign likely structures to the fragments at each MZ value, and explain how each fragment is formed. Okay, so for A, we have this molecule that I've drawn here, and we are told to account for peaks at M to Z 104 and 91. So we're looking for peaks at 104 and at 91. And so, again, the way that I approach these is to see what the difference between our molecular ion peak and these peaks is. So the difference between 122 and 104 is 18. So right away, since there's an alcohol here, that tells me that's going to be a dehydration, since water weighs 18. And the difference between 122 and 91 is 31, which to me is 18 plus, okay. So actually, let me take that back. So to me, that's 17 plus 14. And from an earlier problem, similar to this one, I explained that I always think of these in terms of subtraction. So a methyl group is going to be worth 15, and a methylene group is going to be worth 14. So this 31 tells me that we're losing a methylene group and we're losing an alcohol. So alcohol is 17, methylene is 14. Okay, and so with that in mind, I'm going to go ahead and draw what I think is happening here. And so if we were to do a dehydration, so the dehydration is going to be minus water, as the name implies. And so our product here is going to look like this. So we'll have a double bond here as a result of the dehydration reaction. So CH, CH2, and then we'll have the neutral radical. And so the M to Z here does in fact equal 104. So that's where our 104 comes from. And our other, our peak at 91 is going to be in the form of this molecule. And like I said, I'm thinking we're going to cleave a methylene group and an OH group. So we'll cleave it right here. And so that product is going to be this C6H5 CH, and there will be a carbocation right there. And so the M to Z here is, in fact, 91. Okay. And so I think that that's a good way to approach this type of problem. Think about what your molecular ion is, and then the molecular ions that you're asked to account for, what the difference is between those ions and the molecular ion, and then sort of rationalize what groups you could cleave off to account for that difference. So I'm going to go ahead and apply the same logic to part B here. So our M to Z here is 86. We are asked to account for 4 different ions this time. So 71, 68, 41, and 31. Okay. And so right off the bat, 71 is a difference of 15 from 86. And so this to me suggests losing a methyl group. Because if you remember from the previous page, a methyl group equals 15. So that right there is cleavage of a methyl group. The 68 is going to be dehydration, right? Because it's a difference of 18 from 86. And so this is going to be minus water. 41 is 45 different from 86. So how can we account for that? Okay, so this is going to be a difference of 45. The next one is going to be a difference of 55. So these are obviously fairly big cleavages that we're making, since we're cleaving about half and then more than half of the molecule in each case. Okay, so in any event, well, we'll come back to those two. Okay, so the first two are very straightforward, right? So we can start with the dehydration. So the dehydration is going to be minus water, again, as I've said. And so the product there is going to look like this. So CH2, still have a double bond here. Oops, started too high. So CH2, we still have our double bond. Let me move this down a little bit. All right. Still have our double bond. Still have our methyl group. And so this will now be a CH. Okay, and then we have a new double bond there. And so that's going to be the dehydration product. And of course, to really be correct, we need to put this in parentheses and put this neutral radical. Okay, so that's our dehydration. So then we're going to have three different cleavages. So make a trident type arrow here. Okay, and so our first cleavage, we already know is going to be this this M to Z of 68 is, or pardon me, of 71 is just cleaving off a methyl group. So here, let me include this. So this is the M to Z equals 68. That's a dehydration. So this is going to be the M to Z equals 71. So it's going to look like this: CH2C, CH2, CH2OH, and we will have a carbocation there. Okay, and so this is going to be M to Z equals 71. Okay, so then we should think about where else we could cleave this molecule that's going to get us our 41 and our 31. So there's not too many other spots really that we could cleave this. So I'm going to go ahead and say, well, let's think about cutting this bond and then this bond. And so if we cut that first bond there, the one right at the double bond, we're going to get something that looks like this: CH2C, CH3 with a positive charge on this carbon. And let's add that up and see what that's going to look like. So 3 carbons is going to be 36. 5 hydrogens is going to be 5 more. So that's 41. Okay, and so here's our M to Z equals 41. And if you want to go back and rationalize it the way I started to at the beginning, what are we removing? We're removing 2 carbons for 24, 5 hydrogens for 29, and then an oxygen for 16 more for a total of 45. So this is going to be minus CH2, CH2, OH. Okay, and so I'm going to go ahead out on a limb and say that, oh no, that, yeah, okay. No, that wouldn't work. Okay, so let's see. Okay, I see what's happening. So if we were to cleave this second bond that I'm now going to arrow, if we were to cleave it, but to put the carbocation on this carbon that I'm going to arrow in green, if the carbocation were there, that would give us a peak of 31. And let me draw for you exactly what I mean. So if we were to have this CH2OH with the carbocation on this carbon, that is going to be a total of 12 plus 3 is 15 plus 16 is 31. So that is where our M to Z 31 comes from. Okay. Yeah, and so that's the way to approach this problem. I like working backwards as I started to do on the left over here. It certainly made the first two ions that we were looking for pretty apparent. And then to get to the next two ions, we just had to think about what other bonds we could cleave. And then when we do so, those become pretty straightforward as well. And yeah, so that's the answer to chapter 13, problem number 31.